thanks to Woodworkers Guild of America for sponsoring today's video. I have got a really exciting Shapr3D tutorial for you guys. We're gonna be modeling a nightstand with rounded corners using parametric modeling with variables and expressions. And this is a really powerful tool that a lot of you guys have been asking for, so I cannot wait to get started. But as always, guys, be sure to download the free version of Shapr3D so you can follow along. And later, if you end up loving the app, you can use my code BevelishCreations10 to get 10% off the Pro version and unlock its full potential. But yeah, enough talking, let's get started. So as always, we're gonna be using millimeters for this tutorial, and I'm also gonna lock the grid size to 1 millimeter. And let's start out by going into a front view, and we're gonna sketch a diagonal rectangle starting from this z-axis, and we're just gonna drag it up like this. And then let's set the dimensions to 650 millimeters wide by 375 millimeters tall. So at this point, right now, if I grab the center point, if I drag it up and down, you can see this whole thing rotating, right? We don't want that, so let's undo real quick, and we're gonna drag to select this entire sketch. And we're gonna use the horizontal vertical constraint to constrain those lines to horizontal and vertical. So now if I grab the center point and if I drag it up and down, it's only gonna move up and down. So this is exactly what we want. Now let's go ahead and select this line here and the ground line, and we're gonna set that distance to 255 millimeters, which makes the total height of the nightstand from the top surface to the ground 625 millimeters tall. And just in case you guys are wondering, these values are what I worked out with the client beforehand. Okay, so now that we got all these defined, let's go ahead and use the offset edge tool with loop selected and give the case some thickness. So we can just select one of these lines, and we're gonna pull that in 20 millimeters and click enter to set that value. So as I've mentioned in my past videos, when we use this offset edge tool, even though we define this to be 20 millimeters, that value isn't really locked down. So we still should come back and set these values independently like this. Then we're just gonna go around and do this for all 4 lines. Like that. And this is something that we want to do when we're working with parametric modeling so that things aren't shifting around when we make updates later on. Okay, so before we extrude this guy for our case and round over these corners, you guys should know that this is actually my first time designing and building a piece of furniture with rounded corners. It's completely new to me. I had no idea how to tackle this project. But thanks to today's sponsor, Woodworkers Guild of America, I was able to find different courses on this subject that really helped me form a plan for this build. Yeah, and if you guys don't know, Woodworkers Guild of America is your online resource for woodworking instructions, ideas, and information. It's a community where passionate woodworkers can come together to express their creativity, share their projects, and master their craft. And it doesn't matter if you're just starting out or if you're already a seasoned woodworker, you'll be able to find an abundance of high quality videos that covers everything from beginner fundamentals to advanced techniques. As usual, I went on to Woodworkers Guild of America and I found a bunch of high quality videos and courses on different wood bending techniques, including bent lamination, bending wood with a hot pipe, and steam bending. And of course, all the content are taught by real professionals that knows how to teach as well as how to build. I also found some great CNC tutorials on the website as well, specifically 3D carving, which is exactly what we're gonna be doing with the drawer front later on. So yeah, this is also a great resource for any of you looking to get started with using digital tools. And right now, the first 1,000 of you to click on the link in the descriptions will get a full year of premium membership to the Woodworkers Guild of America for only $1.49. That's right, only $1.49 for an entire year. And this is only valid for new members, and trust me guys, you're not gonna regret it. But yeah, after some research, I decided to use curve bending for this project, which means I can build this entire case out of just a single panel. So let's go ahead and spin out of this view, and we're gonna extrude this outer surface back 380 millimeters. And then we're gonna come back and pick all 4 of these outer corners, and then we're gonna pull to round them over. And for this particular project, I think a radius of 50 millimeters is exactly what I want. And now we're gonna do the same thing for these inside corners. So let's go ahead and pick all 4 of those. And just like before, we're gonna pull to round those over. And since the outside corners are 50 millimeters and the thickness of our panel is 20 millimeters, the inside radius should be 30 millimeters. And this is going to bring us to our very first parametric constraint. So what I want is for this inside corner to always be 20 millimeters less than this outside corner. And we want that to update automatically. And this is going to be perfect for using a formula to define. So let's go to the history sidebar, and we're going to go under the first filleting operation that was used to define this outer corner. And under the radius text box, you'll see this little X icon on the side. So let's click on that, and let me move this to the side so you can actually see it. So if I click on that and then select create length 1 equal 50, you'll see that I added this variable on the top. So length 1 is equal to 50 millimeters, which was the radius that we defined earlier. So once we have that, let's go under the second filleting operation, which was used to define the inside corner of our box. And then let's go under radius and click on the X icon again. But this time, we're not gonna create a length 2. This time, we're gonna select the length 1 variable that we created earlier. So come over here and select that. And then we're gonna type -20 and click enter. Now you see this little function icon next to the text box, meaning that this number here is now controlled by a formula. All right, now let's drag our window back over here. Okay, so now if we want to make a change to this outside radius, instead of changing it in the first filleting operation, we actually want to make the change in the variables on top. So if we change that to 60 millimeters, you see what happened there, right? The inside radius just changed. So let's undo that real quick. Pretty cool, right? And yes, if you're wondering, this does work in 2D sketches as well. So if you remember, let's go under our first sketch. Let's go back to a front view. So yeah, if you remember from earlier, we first defined the height of the case, and then we defined how high this case sits above the ground, right? So now let's say if our client came back and asked us to add 25 millimeters to the height of our case, but we still want to make the total height the same. So we add 25 to the height of the case, but then we have to come back and subtract 25 from the bottom. Which is, not a big deal at this stage of the modeling process, but once we have, drawers, shelves, and legs defined, this can be pretty tedious. So let's undo this real quick, and a better way to define this is, let's first define the total height here, which is 625 millimeters. Let's click on that text box and then click on this little X icon right here. And then we're gonna select create length 2 equals 625 millimeters, which creates a second variable up here. And then we're gonna do the same thing to the height of the case. So click on that text box, then click on the X variable button, and click on create length 3 equals 375 millimeters, adding a third variable over here. And then now we can use both of these variables to constrain the height of the leg. So let's click on this text box and then click on the variable button. And this time we're going to use length 2 minus length 3 and click enter, which adds this function icon next to our text, so you know that this is controlled by a formula. So now if the client comes back and asks us to change the height of the case to 400, we just make that change over here. And the bottom will adjust accordingly, keeping the total height the same. Pretty cool, right? Oh, and one more thing. Let's undo that real quick. So right now, length 1, length 2, as descriptive as they are, we should probably name them something else. So let's right click on the first one and select rename and update preferences. And we're gonna rename that to case roundover. Let's change the second one to overall height. And the third one will be case height. And there we go. Okay, so now that we've got the main dimensions defined, there's just a couple more things I want to do to the case. So the first thing I want to do is let's rotate out of that view. Let's close the history sidebar real quick. I want to add a roundover around this inside front edge here. So usually I like to use bevels, hence bevelish creations, but since this case has rounded corners, I think maybe instead of bevels, a roundover would be better. So let's select just one of those edges is fine, and we're gonna pull that out to 12 millimeters, look good, and press enter to confirm that. And we're ready to move on to the next thing. So let's spin to the back, and we're gonna make a shelf for this. So let's start by sketching on the surface using a diagonal rectangle. And then we're just gonna drop that diagonal rectangle right here on this edge like that. And this is gonna be the dado that our shelf is gonna sit into. So let's give it some dimensions. The height will be 20 millimeters by 8 millimeters deep. Let's set the distance from the top edge of our dado to the bottom edge of our top panel to 140 millimeters. And also let's double click on this sketch and just make sure that our lines will remain horizontal vertical. And of course we want to go the extra mile and use formula to define this position. So let's say that we want to define our shelf position, and let's move this to the side so that there's place for my face over here. So let's say that we want this shelf to always be positioned at a certain ratio of this opening here, if that makes sense. So let's go ahead and click on this 140 millimeters that we set earlier, and we're gonna use a variable to define that. So we're gonna use the case height multiplied by, actually exit this real quick. I need to make a measurement here. So this opening right now is 335 millimeters. So knowing that, let's go back here, and we're gonna use the case height multiplied by, let's see, 140 divided by 375 millimeters. Right now it's 37.3%. So let's just round that to 37%, which is 0.37. Obviously, it's not exactly 140 millimeters, but it's close enough. Now, if you absolutely need 140 millimeters, we can always keep that as a constant, right? But for this tutorial, I want to use variables and expressions as much as possible. So we're just gonna keep the 37% of the case height. Okay, so now we obviously need another dado on the opposite side, right? But instead of doing that all over again, we're gonna use the mirroring function right here. But in order to use this, we actually first need to sketch a line that we need to mirror this about. So we're gonna draw a line from this midpoint down to this midpoint. And let's drop that tool, select this line, and we're gonna turn that into a construction geometry. All right, so now we can use the mirroring function. So click on that, and we're gonna drag to select our first rectangle and then select the line that we just created earlier. And there we go. Okay, let's click anywhere to finish up that operation. And you can see if we make any changes to this rectangle, let's make that 15, the other one will make a change as well. Now let's undo that real quick. And let's spin out of this view to cut our dados. And we're gonna select the two rectangles that we just created, and we're gonna push to cut them out. And we don't want to cut them all the way through because obviously we don't want to see the cutout on the front edge of our case, right? So let's just drag it to some random value for now, which is 280 millimeters. It really doesn't matter. And let's click anywhere to finish up the operation. So since we're using parametric modeling with variables, let's constrain that depth to always update with the depth of our case. So let's go back to the history sidebar, and we're gonna go to this last extrusion that defines the depth of our dados, and open the drop-down menu under distance. Let's click on the variable icon, and let's move this guy over again. Click on the variable icon, and we don't have the depth of the case defined yet. So let's go back to this extrusion here that defines the depth of the case, right? Under distance, let's click on the variable icon and create length 1 equal negative 380. And let's rename that to case depth. Okay, so now we have this variable defined, we can go ahead and define this extrusion. So under distance, click on the variable icon, and we want to make the distance of this cutout to always be the depth of our case to plus 12. Okay, let's move this guy back over here. So basically what we just did was that we made the length of this dado to always be 12 millimeters short of the total depth of this case. And the 12 millimeters is just the radius of this roundover that we defined earlier. Okay, so let's close the history sidebar. And now we just need to create the shelf that goes in here. Now to do that is really easy. We just need to pick the bottom face of one of these dados. And then before we pull this out, change it from offset face over here to extrude. And then pull it out like this. And right now you can see that as we're pulling this out, it's combining this shelf with the rest of our case. So if you look under the items manager, you see that we only have one single body right now, right? That's not what we want. So let's click on this little icon right here and make sure to select new body. And once we do that, you see a second body is generated under the items manager, meaning that this shelf is a separate entity or separate body from the rest of the case, which is exactly what we want. Okay, so instead of pulling this guy all the way to the other side, let's go under the history sidebar. Well, let's click anywhere to confirm that operation first. So under the history sidebar, we're gonna go under our last extrusion that defines our shelf. And under extend, instead of distance, let's change that to object. And then you see that to object is highlighted as red. So let's click on fix. And we're gonna pick the bottom face of the opposite dado as the object we want to extend our shelf to, if that makes sense. That was a mouthful. Okay, so click done to finish that up. So now, it's basically what we just did was if we go under our first sketch, you can see if we change that width of our case to 800 millimeters, our shelf is gonna extend with it. Okay, so everything looks pretty good. Let's undo that. So it's back to 650 millimeters. And I think we're ready to move on to the drawers. Or, sorry, scratch that. One drawer. Each of these nightstands is only gonna have one drawer. Because of the height of the case, having two drawers is just not very practical. There's gonna be a lot of wasted space. So we decided to only have one drawer for each of these. And you know what? I just realized we have a problem with this design. Let's close the items manager real quick. Basically, what I want is for the drawer front to sit flush to this inside edge of the radius. And I also wanted to cover the front edge of our shelf, which it can't do right now. This shelf needs to sit back at least another 20 millimeters. So let's go to the extrusion for the depth of our dado, and under the distance we need to add another 20 millimeters. So this is going to be 32 millimeters. Okay, now we're ready to start working on our drawers. So let's close the history sidebar. And we're gonna start by sketching on the front face of this shelf. So the first thing we need is some reference lines that help us position and constrain our sketches. So since these bottom corners are rounded, the lowest position where we can actually position our drawer box is gonna be above this line right here. And then let's close off this opening like that. Now let's double click to select all four lines, and we're gonna turn them into construction geometry. And then come down here and use the isolate tool to hide everything else that we don't need. So we can focus on just this opening here. All right, now let's sketch a rectangle on the inside of this opening like this. So since we're gonna be using Blum undermount drawer slides, we're gonna set the bottom clearance to 14 millimeters. And then we're gonna need 9 millimeters of clearance on the sides, like this, for both. Just in case you guys want more information on all the measurements needed for the Blum undermount drawer slides, I have a specific video dedicated to just that. So yeah, check that out. But yeah, anyways, let's set this top clearance to 30 millimeters. And we're gonna spin out of this view and extrude the front face of our box 12 millimeters back. And we're gonna sketch another rectangle on the side face right here. And we're gonna start on this back edge and just drag it out like this. And let's set the dimensions to 6 by 6. So this is gonna be the dado that our drawer bottoms are gonna sit into. And also for the Blum undermount drawer slides to work, we need to set this distance to 13 millimeters. All right, now let's spin out of this view, and we're gonna cut this all the way out like that. Now, to actually properly constrain this cutout, let's go under the history sidebar. And instead of extruding it, just some random value like this, we want to set the extend to object again. And then for the object, we're gonna pick this opposite face right here and click done. This way, our dado will always start on this face and it's gonna end on this face, no matter how long this panel is. So now we're ready to move on to our side panel. And like all my builds, I just use a rabbiting joint. But if you do want to know how to model something complex like a dovetail, I have a video on that. So be sure to check that out. Okay, so let's pick this side face again, and we're gonna start sketching on that. And let's minimize that so it doesn't get in our way. And we're gonna draw a rectangle from this top midpoint down to the bottom midpoint, and we're just gonna drag this out this way. And once again, we're using Blum under Mount drawer slides, right? So the depth of our drawer box is kind of predetermined by the length of our drawer slides. And since I'm using 12-inch slides, that limits the total depth of my drawer box to 305 millimeters. So if I'm subtracting the 6 millimeters of overhang for the front panel and 6 millimeters overhang for the back panel, the total depth of the side panel needs to be 293 millimeters. All right, let's zoom out a little bit, or zoom in a little bit. But yeah, if I'm using some other type of drawer slides, we could define the depth of our drawer box based on the depth of our case. But for this particular example, there's really no benefit of doing that. So we're just gonna set that to 293 millimeters. All right, let's double click on the sketch that we just created, and we're gonna click on Isolate Toys to hide the front panel. And with all these still selected, let's use the horizontal vertical constraint to make sure that our lines are not gonna rotate when we make changes later on. Okay, now let's spin out of this view, and we're gonna extrude this surface inboard 12 millimeters. And then just like we did for the front panel, let's sketch a rectangle on this side panel as well. So it's gonna be 6 millimeters by 6 millimeters, and it's gonna sit 13 millimeters from the bottom. And we are going to, oops. And we're gonna push this out to cut our dado for the bottom panel. So once again, let's go under the extrusion properties and extend to object. And for the object, it's going to be this back face. And click done to finish that up. All right, now let's turn off isolate and bring everything back. To make the opposite side panel as well as the back panel, we're gonna create a couple of midplanes. So let's go under add, construction plane, and select midplane. So the first midplane we're gonna define using this side face and this side face, and click done. And then let's do that again. So construction plane for the type midplane. So this time we're gonna use the front and back faces of our side panel. So click on that, and well, this one's hidden. So let's cancel that real quick. And we're gonna hide this front panel, and let's do that again. So add construction plane for the type, it's gonna be midplane, and we're gonna use this front and back face like that. And click done. All right, now let's bring back the front panel. Okay, so to create our other panels, we are gonna go under transform and use the mirror function. So for the first one, we're gonna mirror our side panel. So double click on that and then select this plane that we created first. So there's our other side panel, and click done. Oh, and make sure that keep originals is turned on as well, and click done. All right, so for the back panel, let's do that again. So go under transform, mirror, double click to select the front panel, and then we're gonna select this second plane that we created earlier. So like that, and click done. All right, now that we got all four sides of our drawer box, now we just need our drawer bottom. So it's gonna be similar to how we made our shelf. So let's go ahead and we're gonna double click to select our two side panels. And then we're gonna use the isolate tool to hide everything else. And just like we did with the shelf, let's pick the back face of this dado. Make sure to change to extrude, and we're just gonna pull that out. And to separate these two bodies, click on this button here and change that to new body. And let's click anywhere to finish up that operation. And under the extrusion properties, we're going to change extend to object. And to object, we're going to select this back surface of the opposite dado and click done. Okay, now let's go ahead and turn isolate off to bring everything back. And we're going to go under the items manager and hide all the planes and sketches that we don't need. And totally forgot, we need to cut the joinery out as well. So let's go under items manager and we're going to select all the bodies for our drawer box and isolate. Okay, so to cut these rabbits in the corners, it's going to be really easy. So we're just going to use the subtract tool under the tools menu. And first, we're going to select the bodies that we need to remove materials from, which is the front and back panels. Change this to a plus sign, and then we're going to pick these side panels. And then also make sure that we have keep originals of the removed bodies turned on. And click done. And there we go. So we've got the rabbits cut out on all four corners like that. And let's turn off isolate. And now we're ready to start making our drawer front. And we're getting pretty close to finishing this up, guys. So for the drawer front, we're going to be doing something a little bit different than how we created this front panel here. So instead of drawing on this surface here, we're actually going to create a new plane. So add construction plane, and we can keep the type as offset. And we're just going to pick this front face right here. Click next. And for the offset, we're going to keep it at 0 and click done. And the reason why we need this is because of these rounded corners down here. We actually want to make a projection of the rounded corners onto this plane. So to do that, let's go under tools and we're going to use the project function right here. And now we're going to go around the case and pick all the lines that we need. So let's pick this bottom edge. Definitely need these corners, the vertical edge, and let's do the opposite side. So corner, vertical edge. And since we want our drawer front to be flush to this top edge of our shelf, let's select that as well. And then we're going to pick this plane that we just created. And make sure under projection result, linked sketch is turned on and click done. All right, now let's pick our projection. And we're going to turn isolate on so that everything else is hidden. And we're going to use the offset edge tool to offset this entire thing 2 millimeters inboard. Okay, so sorry, we actually need to delete this top edge right here because we want the top edge of our drawer front to be flush to the top edge of our shelf, right? Okay, so once that's deleted, let's grab this point and we're going to drag it up so that it lays on this top edge. And we're going to do the same thing on this other side. So grab this point until it snaps to this top edge. Okay, now all we need to do is pick this surface and we're going to extrude this 20 millimeters forward to finish that up. Okay, now let's turn off isolate and bring everything back. Go to the items manager. We're going to hide all these sketches and planes. And that looks pretty good. But before we move on to the legs though, we're gonna do a quick check to make sure that everything is updating properly, which is something that we should do at every stage of the parametric modeling process. Okay, so if we go to our history sidebar and we changed our case height to spin to the back so we can see the drawer box as well. Let's change the case height to 425. And we can see that our drawer box updated properly, but yeah, our drawer front did not. And I actually just remembered why. Let's undo that real quick. And we're gonna go to our sketch that defines our drawer front, unhide it, and then we're gonna isolate it. Yeah, so remember what I said about the offset edge tool, that even though we define the gaps to be 2 millimeters here, we still should come back and manually set that gap. So 2 millimeters, we'll do it for the vertical and horizontal lines. Okay, so right now, if we change this case height to 425, let's see what happens. Oh yeah, the corners aren't updating properly. So undo that real quick, and we need a couple more constraints. So yeah, since we can't define the gaps between these corners, right? What we have to do is let's click on this inside corner, click on the radius, and we're going to use a variable to define that, which should be the case roundover minus the 22 millimeter panel thickness as well as this 2 millimeter offset. So minus 22. And we're going to do the same on this side as well. So case roundover minus 22. Okay, now let's try again. So the case height, let's do 425. Oh, still need one more constraint. So undo that, and we're gonna make sure that this corner is tangent to the vertical line as well as this horizontal line. Do it for both sides. So tangent to the horizontal line, tangent to the vertical line. All right, moment of truth. Case height 425. There we go. Okay, undo that real quick. Turn off, isolate, bring everything back. Let's try that again. So case height 425. All right, everything looks good. And if we change this sketch, let's change the width of this case to 700. All right, that looks pretty good. Yep, our drawer box is updating properly as well. So if we undo that, you can see it's adjusting properly. Okay, so yeah, just a friendly reminder that when you're working with parametric modeling, it's always a good idea to check every now and then that everything's updating the way you expect them to. Because if you're too far into the modeling process and then you discover a problem that was made much earlier on, it can be a pretty big headache to make those changes. But okay, now we're ready to move on to the stretchers. Let's spin to the bottom, and we're gonna start by sketching on this bottom face right here. And we're going to sketch 4 lines from one edge to the other, like that. And essentially, these are going to act as our reference lines for positioning and constraining our stretchers. All right, so once we have all 4 lines, let's set the gap between the line and the corresponding edge to 20 millimeters. I'm going to do that for all 4 of them. And for this last line here, for some reason whenever I do this, it always asks me to rotate the surface instead. So let's spin out of this view, and we're gonna do that again. So this line to this outer edge right here. And then now it allows me to change that value. I'm not sure if it's a bug or not, but you know, it's a small fix. All right, let's set that to 20 millimeters, and we're gonna go back normal to that sketch. All right, let's click on any of these lines, and we're just gonna isolate it so we can see what we're doing. All right, let's select all of these lines, and we're gonna make them into construction lines. All right, so now to start on our stretchers, let's sketch a line from this top intersection to this opposite intersection. And once again, we're gonna turn that into a reference geometry. And then we're going to switch to a center rectangle, and we're gonna start from this midpoint right here, and we're just gonna sketch it out like that. And let's set the width of this guy to 30 millimeters. And we want this rectangle to be rotated so that it's parallel to this reference line right here. So what we're gonna do is either select this line or this line, it doesn't matter, and hold down the shift key and select this diagonal line that we made earlier. And we're gonna use the parallel constraint to rotate our rectangle. And there we go. Okay, so for the length of this guy, select one of these long lines, and then also pick our reference line and make them equal to one another. Okay, so this is the profile of our stretcher, and the stretcher and legs is usually where I have the most problems with when it comes to parametric modeling. So let's spin out of this view real quick, turn off isolate to bring everything back, and we're just gonna make some changes over here to make sure that it's updating properly. So if we go into our first sketch, and change the width of our case to 700 millimeters. Okay, you can see our stretcher is updating properly, right? All right, let's undo that real quick, and we change the case depth. Let's do -400. All right, that's updating properly as well. Okay, honestly, I'm kind of surprised, but I'm not gonna complain. Okay, let's go ahead and isolate our sketch again. And we're gonna extrude our profile down 40 millimeters. And there we go, there's our stretcher. Now we're ready to start making our tapered legs. So the first thing we need to do is, while we're here, let's start our sketch on the side face. And the first thing we need to do is define our ground line. So let's pick the line tool, and we're just gonna zoom in here and kind of place that point where that origin looks like. And we're just gonna sketch a horizontal line out like this. And since we can't really snap this point on the x-axis, because yeah, if we spin out of this view, you can see that our plane that we're sketching on is not intersecting the origin, right? So that's why we can't snap to this axis. But it's pretty easy for us to define where the ground is. So let's pick this point to this top edge of our stretcher. And this value, we can use a variable to define it, which should be the overall height minus the case height, and press enter. And there we go, there's our ground line, and let's turn that into a construction line. And now we're finally ready to start sketching our leg profile. So let's go back normal to our sketch, and we're going to start by sketching a line along this top edge right here. So go horizontally and then back down at an angle, and then go horizontally again, and then back up to our initial point to close off our sketch. And now let's go back and set some dimensions. So this top line, I want it to be 80 millimeters. And then this outside angle right here, I want it to be 97 degrees. And this bottom edge, oh, notice that when we click on that edge, it's asking if we want to select the short edge or this long edge that we created earlier. So we want this short edge. And we're gonna make that 25 millimeters. And lastly, we're going to set this distance right here to 10 millimeters. This value really doesn't matter. We can make changes to it later depending on how things look. Okay, so once we have the leg profile, let's turn off isolate, select our profile, and then turn isolate on again so that we only see this guy. And we're going to extrude this surface back 30 millimeters. So the same thickness as our stretcher. And now we're ready to make some joinery. So for these legs and the stretcher, I usually like to go with a bridle joint. Now let's go ahead and start sketching on this top surface right here. And just like what we did earlier with the stretchers, we're going to draw a reference line from point to point. And let's turn that into a construction geometry. And then we're gonna sketch a center rectangle right at this midpoint. And then select the long edge to our reference edge, make them parallel to one another, and then make sure that the long edge and this reference line are equal to one another. And then let's set this width to 10 millimeters. All right, there's our profile for the bridle joint on the leg. Now all we have to do is pick this surface and push it down 40 millimeters, so the height of our stretcher. Now notice that we have this sliver of material left right here. All we have to do is select that surface and push it out to get rid of it. All right, so let's turn off isolate, bring everything back, and we're gonna use the mirror tool to create our second leg that's gonna sit over here. But the first thing we need to do is create a mid plane. So go under add, construction plane, mid plane, and we're going to use the end faces of the stretcher and click done. All right, let's go under transform, mirror, double click on our leg, and then click on the plane that we just created and click done. All right, now we have our two legs and our stretcher. Now we just need the mating joinery on the stretcher. Let's select the stretcher and legs and isolate those. And we are going to use the subtract tool to cut out the joinery. So first we're going to select the part that we're removing material from, which is our stretcher. And then we're going to pick the legs as our cutting tools. And make sure that keep originals of removed bodies is turned on and click done. All right, so now if we move the stretcher up, you see the mating joinery is now cut. All right, let's undo that real quick. And to remove the material on the ends here, all we have to do is select the side face and just push them through to cut them out. Okay, so now this is one leg assembly. We need a second one, right? And if we bring everything back, what we can do is use the mirror function again. And we also need a midplane that bisects our case, which I believe we've already made. I think it's one of the, yeah, it's this guy right here. Let's go ahead and use the mirroring function. And we are going to select the leg assembly. And then use this plane here to mirror this guy over and click done. All right, that looks pretty good. Oh, one more thing. We need to cut the joinery between the two stretchers, right? Let's hide the planes that we no longer need to just keep things simple and clean. And actually, we only need these two stretchers for our next operation. So let's isolate those. So to join these two stretchers together, we're going to use a lap joint. And the easiest way to create this, at least I think, is to use the intersect tool. And we're going to click on both of these stretchers. So the intersect tool, as you can see, is usually used to create a body that's formed between where two parts intersect. So what we want to do is make sure that keep originals is turned on, or else the rest of the bodies are removed. And let's click done. And so once we do that, you see that a new body is created where the two parts intersect, right? And we're actually going to use this to help us create our lap joint. So let's go ahead and hide one of these stretchers. And we're just going to sketch on this top face right here. So with the line tool selected, we're going to trace the profile of that new body like this. And then let's rotate out of that view. And let's hide that intersect body. And now we're going to pick this profile here and just push that down halfway, so 20 millimeters. And click anywhere to finish up that operation. Okay, now let's bring back our other stretcher, which is, where is it? Oh, here it is. And we're going to use the subtract tool to cut out the opposite joinery. So we're going to select this guy first and then this guy. Make sure that keep originals of remove bodies is turned on and click done. Okay, let's turn off isolate, bring everything back. Oops, our legs as well. And we are finished as far as the case and the legs goes, but the drawer front is looking kind of boring, right? Yeah, right now I'm thinking of making some drawer pull out of wood that's gonna be cut on a CNC. Well, I'm not really sure yet, but I'm thinking it's gonna look something like this. Let's sketch on that front face. And we're gonna sketch a line from midpoint to midpoint. And that's going to be our reference geometry. And we're just going to draw a big circle right in the middle. So about, I don't know, 110 millimeters. So in my mind, what I'm thinking is it's going to be a circular drawer pull that's going to be smaller at the base. So instead of 110, maybe just 80 millimeters. And then as it moves away from the drawer front, it's going to get bigger. So let's exit the sketch. We're gonna add another construction plane, and the type is offset, and it's gonna be offset from this surface right here. And we're gonna go 30 millimeters. And click done. And then let's project this circle onto our new plane. All right, so let's start sketching on this new plane now. And now we can use the center point that's projected from our original circle as the center point for our new circle as well. And maybe this one 120 millimeters. And then let's make this projected circle into a construction geometry. Oh, and one more thing. Of course, I want these circles to change size based on the height of our case, right? So let's spin out real quick. Let's hide this sketch in the plane. So instead of just a diameter of 80 millimeters, we're going to use a variable. We're going to make it 20% of the case height. Okay, 75. Pretty close to that 80 millimeters. All right, let's bring back our other sketch. And we're going to make that diameter maybe 30% of the case height. Okay, yeah, so something like this. Let's extrude this back 8 millimeters. And then we're going to use the loft function to finish up that body. So something like this, but let's use these points to change the profile of that loft. Okay, so let me zoom in here so you can see better. So if we change that, it changes the curvature of that loft. So yeah, something like this. And let's click done. Okay, yeah, something like this. This looks pretty good, right? It's sticking out a little too far, so let's change that plane offset to maybe 25 instead. Yeah. Okay, let's change that loft a little bit more. Yeah, so something like this. I'm probably gonna cut this guy out on the CNC, like I said earlier. Right now we have two separate bodies. So we have this loft and then this extrusion. So let's go ahead and combine them using the union tool and click done. All right, so now we've got one piece and it's ready to be cut out on the CNC. I'm not sure if this is, the final thing. I'm probably gonna end up making some prototypes and see what looks best, right? But yeah, for now, everything looks pretty good. Let's hide all the sketches. Let's close the items manager. Yeah, this looks really good. I'm sure I'm probably gonna make some small changes here and there once I start building it, but so far, this looks really good. Yeah, I hope you guys have fun modeling this with me and you were able to learn how to use parametric modeling in Shapr3D with variables and expressions. Yeah, if you guys found this helpful, be sure to let me know in the comments and leave me a like. And if you haven't yet, be sure to hit that subscribe button. I don't know what you're waiting for. I hope to see you guys in the next one.